Okay, this is a different recorder. Let's see if it works. Okay, wow, that needs to go away. It's like a screen cap that is part of this. Okay, anyway, this is part 2, and I got, we just set up that this is cosine. We're proving the cosine identity. And one thing we can set up, we just set up a location of these 2 points. And now if we've got that this is cosine u sine u, that's the coordinate, and this is cosine b sine b, then we can find out through the distance formula what the distance of this of BC is, the segment BC, not the arc BC, but the segment. And it is cosine u minus cosine b all squared plus sine u minus sine b all squared. Now that's, and then the whole, take the square root of the sum of those 2 things. Now the distance formula is x1 minus x2 squared plus y1 minus y2 squared. So, and then take the square root. Now, for reasons that you'll see in a minute, we're going to square both sides and just imagine, so this BC squared is that whole thing with the square root sign off. Okay, so we now see that that BC squared is that through the distance formula. Now we're going to come up with another way of calculating what this BC is. We're going to look at that triangle, and we're going to use the law of cosines on that triangle. Now what we know about this triangle is that this is 1 and this is 1. And so by the law, and we don't know that angle, but that's what we want to find out, is what that angle is. Well, I guess what we want to find out is what BC is, but in any case, we'll use that angle in between the ones for our law of cosines work. So now you probably already see why we found BC squared up here, because when we use the law of cosines of this triangle, the law of cosine says that this side squared, I'll say c squared, equals a squared plus b squared minus 2ab cosine this angle. And this angle we know is u minus b. So there we have that. Now the other a squared is, those sides were each 1. So bc squared equals 1 squared plus 1 squared minus 2 times cosine u minus b. And we can simplify a little. That says u in case you have a hard time reading that. And now the next thing we're going to do is simplify that, which means we're going to expand this. Now, that sounds weird, but and I'm not going to do it right here, but really what I want to show you right here is how I'm going to do it on the next page. Basically, you've got to get used to treating cos u and cos b just like they're x and y. So what's x minus y squared? Well, by FOIL, we know what that is. So we've got to use that pattern on the next, on this stuff, both of them. So let me show you what that's going to look like. This is what it looks like. So cosine u squared is cos squared u minus 2 cos u cos v plus sine squared u plus sine squared, this is a v, minus 2 cos v sine v plus sine squared v. Kind of messed up. Here, I'll fix it. So this should be cos squared v here, right? X minus y squared, so plus y squared would be here. So it's cos squared v, cos squared u, cos squared v, and then sine squared u, sine squared v. And this should be sine v, sine u, sine v, sine u, sine v. So cos squared u minus 2 cos u cos v plus cos squared v plus, so that's this part, then plus sine squared u minus 2 sine u sine v plus sine squared v. Okay. For the next part, the next step, you're going to use the identity that for any u, v, anything, theta, cos squared theta plus sine squared theta equals 1. So this plus this equals 1, and this plus this equals 1. So therefore, those four terms are going away, and they just add up to 2. So what we got is 2 minus 2 cos u cos v, and plus minus 2 sine u sine v. All right, remember to pause if you're struggling. So if I go back, so this is bc squared, so is this. So this equals that. So that's how I'm going to set up my equation. Basically, this equals that. And just without even rewriting, I'm just going to say, okay, I'm going to cancel the 2 on both sides. And so now I've got, let's see if I can. If I cancel the 2 on both sides, now I've just got negative 2 cos u minus v over here, and this over here equals, and for your next step, you'll see that if I just divide by negative 2, I'll have that identity that I wanted in the first place. So if I divide this side by negative 2, I'll get cosine u minus v. Just imagine this going away, dividing by negative 2. Now cosine u minus v equals, divide this by negative 2, and you'll get this will go away, and this will become a plus, and this will go away, and there you go. Your identity is cosine u minus v equals cos u cos v plus sine u sine v. And allegedly, you could use that to find some other the other identities as well, but I won't get into that. I'm going to stop this for now, and maybe we'll go over some more problems like this, but that's as far as we're going to go here today. Thanks.
So it looks like this bar was in the way. Let's see if that messed you guys up too much. That's the big.
And for your next step, you'll see that if I just divide by negative 2, I'll have that identity that I wanted in the first place. So if I divide this side by negative 2, I'll get cosine u minus v. Just imagine this going away, dividing by negative 2. Now cosine u minus v equals, divide this by negative 2, and you'll get this squared equals a squared equals that. So that's how I'm going to set up my equation. Basically, this equals that. And just without even rewriting, I'm just going to say, okay, I'm going to cancel the 2 on both sides. And so now I've got, let's see if I can.
If you got it, you should stop watching. There's nothing new coming. I'm just trying to make sure you can, if you need to see the bottom better,
both sides,
I'll try to get you a better view. This is ridiculous.
Negative 2
but
cos
thanks for watching.
minus v over here. And this over here equals, and for your next step, you'll see that if I just divide by negative 2, I'll have that identity that I wanted in the first place. So if I divide this side by negative 2, I'll get cosine u minus v. Just imagine this going away, dividing by negative 2. Now cosine u minus v equals, divide this by negative 2, and you'll get this will go away, and this will become a plus, and this will go away, and there you go. Your identity is cosine u minus v equals cos u cos v plus sine u sine v. And